Okay, so we're working on solving inequalities, and these inequalities come in several forms: quadratic, polynomial, and rational. One of the things I found annoying, though, is that, and I'm gonna switch this on you with the problems. They're asking often for inequality notation when what we're used to doing on all previous assignments is interval notation. So when you go to the quiz, we're going to do this first problem, and I'll show you what I mean. Okay. So here's how these work. First of all, we're going to find the critical points, and the critical points are going to be where, this one starts out with a 0 on one side. We're always going to have a 0 with all of these kinds of functions, or we're going to get there at any rate. On this one, though, it's really easy to factor. And this gives us our critical points. So that means we've got zeros at -5 and -2. This is going to be the place where, at the zeros, is going to be the place where the function changes sign. So going back to the original question, this quadratic, where is this quadratic less than or equal to 0? It's actually asking, where is this quadratic negative? So we found the critical points, and in order to answer that question, what we have to do is set up a table where we test each interval. So my intervals come from the zeros. It's going to be -infinity to -5, -5 to -2, and -2 to positive infinity. And at each of these intervals, we're going to pick a test point, T-E-S-T, and we're going to calculate the sign of the function. So let's see, a number between -infinity and -5, let's just pick -6. I find it's good around infinities to just pick a number that's close to that number, because then you can figure out if you have a factoring error. Okay, between -5 and -2, let's just say -3 or 4, both will do. And between -2 and infinity, well, I'm going to pick an easy to calculate number 0. So what I do is I plug this in to my factors. Okay, because with the factors, it's easy to see, and all we need to know is the sign of f of x. So all we have to determine by plugging in our test numbers is what is the sign of each piece and the overall sign of f of x. Well, if I plug in a -6 to x plus 5, I'm going to get a negative. And the same thing happens if I plug in a -6 to x plus 2. I'm going to get a negative. Now, two negatives lead to a positive, so my function is positive there. Let's try the same thing with a -4. If I plug in a -4 plus 5, I get a positive. And I plug in a -4 plus 2, I get a negative, which gives me an overall negative. Same thing with 0. I get a positive times a positive. I'm running out of room. That gives me an overall positive. You should expect that the signs will flip-flop the same way we've seen them in the past. So where is my quadratic less than or equal to 0? Well, it's where it comes out overall negative, so this interval. And they're asking for it in inequality notation. And I'm going to switch back and forth. So what you see on my test table is my interval notation. Writing that in inequality notation looks like this. X is less than or equal to -2, greater than or equal to -5. Now let's graph that. Closed point at -5, closed point at -2, and all our solutions are between the two. Okay, let's take a look at the next example. We're going to solve the inequality. We're actually only going to do A. The only reason I put B there is to see that with a couple solving steps, you are going to get to something that looks like A. Okay, so always get all your terms on one side if it's something you need to factor. Okay, this is also easy to factor. Looks like x plus 4, x minus 1. And that allows me to set up, so I've got my zeros at -4, and positive 1. So let's set up a test table. My intervals are negative infinity to negative 4, between negative 4 and positive 1, and then 1 to infinity. Pick some test points, negative 5, 0, and 2. And the value of my function. So let's take a look at my original inequality. This is asking where this quadratic is greater than 0, so it's really asking where this quadratic is positive. So I'm just going to write f of x here, and when I plug in a negative 5, I get a negative and a negative. So I multiply that, I get a overall positive. I plug in a 0, I get a positive and a negative. And that gives me an overall negative. And then plug in a 2, I get a positive and a positive, which also goes positive. So where, and they're asking for it in interval notation, good, because that's what I'm using in the top. So where is this positive? There and there. So negative infinity to negative 4, union 1, comma, infinity. Okay, and there's no equal sign, so an open point, and arrows going both directions. Okay, I'm going to stop this and see you on the next one.